With this video, we're going to take a look at polar derivatives one more time. Hopefully you have a bit of idea of what they look like, but if not, if it didn't go too well yesterday, then this will hopefully clear things up for you so you know how to take a derivative with a polar equation. So we're going to start out with the polar equation you were looking at yesterday. R equals 2 cosine of 3 theta. So we're going to take a look at that equation, and we are going to take the derivative of this polar equation. And so to start with, we have to take this polar equation and convert it into parametrics, because we know how to take the derivative of parametric equations. It's not too hard. And so we have to turn this into a parametric equation almost. And we use the rectangular conversion that you've been working with. So when a polar coordinates x is going to be equal to r times cosine theta, and y is going to be equal to r times sine theta. And of course the r comes from the equation we have for r. So when we want to figure out what x equals, we have to plug in r there. And that simply comes from right triangle trigonometry. And so you can draw a right triangle, put in theta, and put in r as the hypotenuse, and you can find the value for x and y pretty easily. But if we want to take the derivative, we have to remember that dy dx, when we take the derivative of a polar equation, that is going to be equal to the derivative of y with respect to our second variable, which in this case is theta, d theta, over the derivative of x with respect to our other variable theta. And that's what we're going to use to find this derivative. So first I have to take the derivative of x. Here we're going to take the derivative of this one, and then we're going to take the derivative of this one also and use that in our formula. So I'll do that over here to the side. So I'll start with dy dx, or dy d theta. Okay. Sadly, this is going to take a bit of a chain rule here. A chain rule and a product rule, actually, because our function y, which is r sine theta, we'll plug in r. R is 2 cosine of 3 theta times sine theta. So when I take that derivative, it's going to require a product rule. So we'll do that. The derivative of the first, the derivative of the outside cosine is negative sine, so it's going to be negative 2 sine, the inside doesn't change, 3 theta, times the derivative of the inside, which is 3. Alright, the derivative of the first times the second, which is sine theta, plus the derivative of the second, which is cosine theta, times the first, which is 2 cosine 3 theta. As you can see, that is kind of long, but it is just the product rule. Now to do the same thing for x, we need dx d theta. This is again going to be a bit long. So again, we need, what does x actually equal? X equals r, which is 2 cosine of 3 theta, times cosine of theta. Sadly, we cannot combine the cosines because the insides are not the same. So it has to stay that big, long equation, which is going to again require a product rule. So the derivative of the first, I'll highlight it here for us, the derivative of the first. So I'm going to do a little bit in my head here. I know I'm going to multiply the inside times the outside. So that is going to be negative 6. Derivative cosine is sine of 3 theta. I already multiplied by the 3 to get negative 6, so I don't need to do it again. Times the second, which is cosine theta. Alright, plus the derivative of the second, cosine theta is our second. Derivative of cosine theta is negative sine, so I should probably switch that to a minus sign over here. Sorry about that. Minus sine theta times the first, which is 2 cosine of 3 theta. So just as long, in the first one you probably should multiply the negative 2 and the 3 to get negative 6 as well. So now we know dy d theta, we know dx d theta. All we have to do is put it in one big fraction to get our actual derivative. So dy over dx is going to equal, let's see, I'll multiply them this time. So I have negative 6 sine of 3 theta times sine of theta plus, and this time I'm going to put the 2 cosine 3 theta first. 2 cosine of 3 theta times cosine of theta. So all I did is just I wrote this whole thing here. I did flip-flop these two though. It's multiplication, so you can do that. So now that is all going to be over dx d theta, which is negative 6 sine of 3 theta times cosine theta minus, I'm going to put the 2 cosine of 3 theta there times sine of theta. So again, I just flip-flopped these two to make it look a little nicer, because you can see here the 2 terms there are the same and the 2 terms there are the same above each other. Sadly though, because we have this addition and this subtraction, we can't actually simplify anything, but you can see that there is a pattern going on here. And so we want to take a look at that without the numbers, and that pattern will become a little more obvious. But that is our polar derivative. It's a little complicated, it's a little long, but hopefully using parametrics it makes sense where it comes from. So let's do this without the numbers, and you'll see it's actually a little bit easier. So I'll use green this time. So if we're just using numbers, we have to start with x equals r cosine theta and y equals r sine of theta. So when we want to take the derivative, we are again going to find dy d theta, which, just like we use the product rule up here, we're going to use the product rule down here, only it'll be a bit easier. So the derivative of the first times the second, etc., etc. The derivative of r is simply r prime times the second, sine of theta, plus the derivative of sine is cosine, so I'm going to put my cosine theta, times the first, which is r, and I'm going to put that in front. Alright, now dx d theta. Alright, it's again going to be a product rule, first and the second, so it will be r prime cosine theta And then the derivative of the second, the derivative of cosine is going to be negative, so this is going to be minus, and sine of theta. But of course we have to multiply by the first, which is r again. So there's the general formulas, and if we want the derivative, dy over dx, we have to divide those two. So it is r prime sine theta plus r cosine of theta over r prime cosine theta minus r sine theta, once we put all of those together. It's a complicated formula, and so I would not recommend memorizing this. You would get something wrong. I would not recommend memorizing it. Instead, what I would recommend memorizing is this here. That's not too bad. X equals r cosine theta, y equals r sine theta, and even if you forget that, you can make your right triangle. Put theta in there, put r here, and you can figure out what x and what y are to get them. Once you have that memorized, hopefully you remember this step up here also, that the derivative is dy d theta over dx d theta, and then you can build your formulas from there, just like we did in the first problem, and hopefully whatever equation you get is a little easier than our example. But that allows you to find the derivative of any polar equation. I hope that helps.